Okay, so today we're going to be talking about SQL, but before that, some questions about a bunch of random things. First off, we have the difference between continuous and categorical data. We will definitely dive more into this let's see, towards the end of phase 2, like the specific differences between categorical and continuous data. But I guess really briefly, we can talk about it using, let's talk about this car data set. Continuous data is any variable, any column that, can be measured on a continuous scale. Again, like the degree of like incrementing does depend on the data set. So in this case, I think all of them, they increment by like whole numbers. I guess not for miles per gallon, but yeah, these are considered continuous. Variables like displacement, horsepower, pretty much anything that, like, if you plot a histogram of, so let's hope that I remember this syntax, but let's do miles per gallon for now. I want to see if this will work. There we go. So this is just a histogram of the miles per gallon, and it looks like this. And basically, there are no specific groups of data, and this is continuous. To contrast, if I were to plot, for example, origin, I wonder if histogram will work for origin. So with origin, even though this is a histogram, there's very distinct places in which the bars are plotted. So in this case, if you were to inspect origin, you can see it's very clearly 1, 2, and 3. And so this would be something that's considered categorical data, where it's literally categories. You cannot have an origin of 1.5, 2.5, so on and so forth. In other data sets, you might come across categorical variables, like actually in your phase 1 final project, you'll come across genres, because you'll be talking about movies in this final project. But genres is categorical, just because one is not numerical, that's a big sign, but also, you cannot have like between genres. Yes, you can have multiple categories of genres, but you won't have like, I don't know, 1.5 of one. And yeah. Did that answer your question, Ali?
Yes, thank you.
You're welcome. Another question I had was about enumerate and using enumerate with plots. And I believe that's like when talking about subplots. There is one lab, I believe, that talks about doing subplots in matplotlib with enumerate, where basically you just take into account, or you're just remembering, like, enumerate basically will turn anything into a list of tuples with, actually, yeah, let me just do this real quick. So let's say I have this list of variables A, B, and C. And let me just call this, I don't know, letters. If I were to call enumerate on letters, and this is actually something that can be pretty useful for one of your Python problems that you're solving. If you enumerate letters, one, you have to course into a list. I always forget that. But when you do an enumerate on something, it sort of assigns it like an index and turns it into a list of tuples with index and then value. And so this is used in matplotlib to do subplots, just so you can you can remember, when you're looping through different subplots, that's one way you can keep track of the plots. So there's that. And the question was, can you use enumerate in other plotting libraries? So this is more in context of subplots. I believe that's probably the only time you'll use enumerate. I was just looking at the documentation, and this is Plotly. And because Plotly does take into account like the rows and column numbers, you can use enumerate for it. So this is this. For Seaborn subplots are a little bit different, because Seaborn, as I mentioned yesterday, works very well with data frames. It seems like for multiple subplots, you don't even have to do that like fig and axes thing, which is awesome. I think these are called Facet Grids. And basically you can plot multiple things all at once without having to define multiple axes. So yeah, hopefully that answered that question. Anything else before we dive into SQL? All right. So as mentioned on like the homeroom page here, SQL is a very standalone topic. So if you find yourself a little bit behind, or maybe you want to focus more on pandas and visualizations, which will be more important for the project, definitely like feel free to skip this section. This is something you can come back to whenever. So to talk about SQL, I know it was part of like, I think it might be part of like that pre-work a little bit, but anyways, yeah. SQL is something that you can choose to use in your projects if you'd like. It's just not a necessity. But good to know about it. A lot of technical interview questions are SQL questions, but I'll talk about what kind of interview questions will come up. So yeah, all right. To get started, SQL is a kind of relational database. So that's why this topic is SQL and relational databases. So let's start big and then whittle down into SQL. What is a database? So databases store sets of data that can be queried for use in other applications. A database management system supports development, administration, and use of database platforms. So in general, databases store data. Whoa. Never mind. Relational databases, or for short, RDBMS, is a type of database management system with a row-based table structure that connects related data elements and includes functions that maintain security, accuracy, integrity, consistency of data. The main part here is it's a row-based table structure. So imagine a bunch of CSVs or like a bunch of Excel files. It's the row-based table structure that is unique to SQL. We'll actually see in topic 8 at the start of next week. Topic 8 talks about databases that are not in the table structure. So the main two kinds of databases are table structure, not table structure. And relational databases are row-based, which has that table structure. So what is SQL? SQL, usually pronounced SQL, but some people call it SQL as well, stands for Structured Query Language. SQL is a programming language that's used to communicate with data stored in these relational database management systems. So basically a bunch of data will exist in a database, and SQL is the language that you will use to query them. One thing to note is that some databases can also exist in different non-SQL languages. So, but for the most part, any like table-based database management system is likely to be SQL. One kind of annoying thing that I've learned over the years is that some companies have created their own database types that have their own languages, and that, I mean, if you end up working for one of those companies, they will probably, put you through that training. So what's great about SQL is that it's very similar to the English language, which makes it relatively easy to write, read, and interpret. There are many, many different levels of SQL. So for data scientists purposes, mainly what we use SQL for is just to retrieve data, just to query data that we will use for analysis. We'll see later on, but like SQL is not like a CSV where you can see all your rows. It's not like Pandas where everything is visible. It's actually quite opaque, but you have to write these queries to extract the data from the databases. SQL also exists in many levels. For data scientists, we don't have to do all of the advanced SQL things that SQL can do. For us, it's really just to get the data. But just for you guys to know, in SQL, you can actually write functions and like do things to your database before querying them. But very unlikely you'll need to do that. Probably I only know like one data scientist that actually worked fully in SQL, and they were writing like 40 lines of SQL queries, like 40-line SQL queries. But I will say that's on the rarer side, just because that same thing, you can just query all the data and then do that analysis and do that manipulation in Python, which is a much more visible, I don't know, it's just a lot easier to see. Questions so far about setting up SQL?
The language we are learning here in Sql is working both on Linux operating system and Microsoft, because as far as I searched it up, Microsoft has its own, Linux has its own, I don't know what's the difference between.
Yeah, so yeah, SQL, there are many different flavors of SQL. Actually, I think, yeah, now's a good time to actually talk about it. I really like HackerRank for practicing SQL, and I think this is just a good place to show you all the different kinds of SQL that can be used. So let's say in one of these SQL challenges, here you can see that there are already multiple SQL languages. The most common one, I would say, because MySQL is used in AWS, so any Amazon Web Services database would use MySQL. I know you also have the option in AWS to change it to a different one if you prefer, but by default is MySQL to my knowledge. Oracle also has written their own SQL language. And yeah, this is the Microsoft one. I'm not too sure which one the Linux uses, to be honest, but I'm sure we can find out. But all
The
this,
Oracle.
What's up?
Yeah, the Oracle one is the Linux one. Linux one.
Okay,
yeah.
Awesome. Yeah, so there's a bunch of different SQLs that exist. They're all structurally very, very similar. So very likely you would just learn one. And then if you ever needed to translate to a different one, it would be like very specific functions. I know like one of them, the way that you look up words might be a little bit different. But for the most part, if you know how to structure a SQL query, it's mostly just like fixing specific, like the names of functions or the names of methods that you're using within a SQL query that sometimes change. So I would say like that's not a big thing to worry about in your SQL interviews. They are also pretty SQL language agnostic. So I wouldn't worry too much about like the different SQLs. MySQL is the most, I guess, like what's the word? Like the most general SQL, I think. So I mostly do MySQL in MySQL. Every interview I've had, I've managed to do in MySQL fine. But yeah, that's a good question. So now that we're here on HackerRank, which I had sent out one morning practice problem from HackerRank, a lot of really good SQL problems is just like they set up, like they tell you what the databases look like, tell you what you want, tell you what they want, and then you just have to write your query. A really good place to practice your SQL queries, especially when it's like interview time. But all right, let's go back to our notebook. So as I sort of gave you a preview of when we looked at HackerRank, every time you're given a SQL database, you have to be given a schema. SQL databases are quite opaque, and again, I'll like show you what I really mean by that, which is why you kind of need this schema to tell you what tables exist in the database and what columns exist in each table. So let me like zoom out a tiny bit here. So each of these boxes is a table, and each of these rows are columns in each table. And so you can see here, this one probably has to do with like the org chart of a company. So you have like different departments, different department managers, titles, employees, salaries, things like that. And the main thing about SQL is that they're relational. So for example, if you have employees here, if you have employees here, you have their names here and you have their indexes. You can find per employee, look up per employee their salaries that exist in a different table. And all of these lines, if you're very interested in databases, these lines have meaning. I think it's like there is a one-to-many, there's like a one-to-many relationship. And I'll talk about these relationships later, but very briefly, just to like, as a precursor, this means, this like line means that one employee can have multiple salaries. And through like looking at this database schema, you can sort of infer that, all right, one employee maybe like has worked multiple jobs or for a long time at this company and has different salaries ranging for different date ranges. So maybe like they got like, I don't know, a raise every 6 months or something. And so they have different salaries, and this table keeps track of all of that. And what's great about this one-to-many relationship being in two separate tables is that if we wanted to keep track of all the salaries with the employees in one table, you would either end up with like, you know, maybe duplicate rows for each employee for each like time their salary changes. Or you also might end up with possibly, maybe you would do like first salary, second salary, third salary as like added columns. And that just makes it a little bit inconsistent sometimes. So having it in this format happens to be more efficient. Any questions about a schema? Cool.
I have a question.
Yeah.
Is there no way when you open the file to have it list all the table names for you if you don't have a schema, so you know what to look for?
There is a line of code that does that, but you pretty much will always be given a schema with every SQL database. That's just like standard, because again, like SQL files are very opaque. That's why. But yes, there is one code. There is a line of code that you can write to give you all the table names. I just don't have it in this notebook. But yes, that does exist. All right, let's take a look at relationships. So I already alluded to, the one-to-many relationship where like an employee can have multiple salaries. Relationships to just be aware of is just that there are one-to-one, one-to-many, and many-to-many relationships. Being aware of these relationships actually comes in handy when you're thinking about doing your joinings. We kind of talked about joins when we did our pandas, when we were putting data frames together. We had our inner, outer, left, and right joins. Those carry over into SQL. And so the way that Pandas does joins, same way as SQL does joins, and therefore it's also kind of important to consider what the relationship mappings are to decide, all right, which will be my left table, which one am I joining to, all good things to consider. So just as examples, one-to-one relationships, every customer has one address. In this case, if every customer just has one address, this is a one-to-one relationship. If a customer has, now we're looking at one-to-many, we have customers and orders. Imagine this is an online store. Customer can make repeat purchases. So therefore, this can be a one-to-many relationship. Even if one-to-one relationships exist, once there's a one-to-many relationship, you would consider it a one-to-many relationship. And finally, you also have many-to-many relationships, where let's say you have a list of items and a list of orders. An order can contain any combination of items, and items can be in multiple orders. And so this is known as a many-to-many relationship. For specifically many-to-many relationships, you might find in certain SQL databases something like a junction table. There are multiple names for this. I forget what the others are now, but this middle table is a junction table. So imagine if you have, a table of orders, and maybe with orders, you have like timestamps of the orders. Maybe you have where the order is going, address for the order. Perhaps you have, I don't know, number of items in an order as a column as well. And on the item side, you have things like, all right, inventory, when was this item stocked? Perhaps like maybe like a level of popularity of this item, basically features about the item. This junction table makes it easier to join these two tables together without complicating the existing columns of each. So let's say, so this table would basically look like very often just like order ID and item ID, and that's how you're able to join the two tables together. This will make more sense, I think, as you try different examples of SQL. I don't think we'll have an example later on, but we'll see. Questions so far about these relationships? Cool. Let's see. All right. So SQL data types. So as we had pandas data types, remember we had objects, which are basically strings for the most part. We had int 64, so we had float 64s. I think those are the main ones. SQL has many data types as well, actually more than pandas. So SQL data types, this is important, especially when you are creating a SQL database, which for the most part, data scientists don't mostly do. But just so you know, SQL does have specific data types, and each column is configured with a specific data type. So you have your numeric data, you have integers, floats. Other words for that is decimal and numeric. And you have all these other variations for numbers. These, just to like summarize, all sort of do the same thing, but depending on your database and what you're using it for, let's say you only have small, very, very small numbers, using something like tinyInt would just make your database a little bit more space efficient, if that makes sense. For the most part, it's not something we have to worry about too much, but if you ever come across a database with like a type that doesn't look as familiar, and it's numeric, that could be why. Date time objects, so you have date time, literally date time, timestamps, things like that. When you have strings, you know how in Pandas we call them objects, here we call them characters or char. Varchar is one as well, or more typically you might see text. When you're defining your database and you're creating a table, most of the time I see people use text. This Unicode character is just more specific. If you have a specific encoding, then you would use this. Binary, true, false, and then miscellaneous. So sometimes within SQL databases, you might have like a big chunk of text that doesn't typically look good in a table, but those are actually called blobs. Blob is the most common one that I've seen. And also, we're actually going to talk about JSON and XMLs next week. But that's just another data type. Just imagine like a giant dictionary. All right, so in Sqlite, we'll talk about once we get to this next part. But let me actually zoom in. This is kind of small. Sqlite is what we use in Python to interact with SQL, and it uses MySQL as well. So these are the main data types that we'll deal with Sqlite. So just text, numeric, integer, real, or blob. And these three are actually all numerics. All right, so we're going to test out some SQL. And I'm also going to talk about how we work with SQL in Python. And again, talk about like why SQL databases have this like opaque nature to it. Let me really quickly make sure that this database is loaded up. All right, there we go. So here we're going to play around with a Pokemon database. What I've learned is that not everybody might know what a Pokemon is. So does anyone need an explanation of what that is? All right, fine. I'll explain. Basically, Pokemon is this game, Japanese game, that you basically collect a bunch of little monsters and they have attributes. I'm a big Pokemon fan, so this made a lot of sense to me, but I realized that not everybody knows what this is. So just wanted to make sure. But this is a database that has information about Pokemon. Here we have Pokemon that each Pokemon has an ID number associated with it, name, a height, weight, and a base experience. So you also train your Pokemon so they gain experience. So they start with some base experience. Here you also have different Pokemon types. There's, I think, about like 20 different types that Pokemon can have. And basically it means that are they a fire type Pokemon or a water type Pokemon? It just gives them different strengths, and like different types are like strong against other types. Basically think about like if you have a fire type fighting a water type, the water type would like extinguish the fire. That's how I think of it. So type of Pokemon is also important. And here we have kind of what I talked about earlier. We have this junction table because we have a many-to-many relationship. For more context, Pokemon can have different types. You can have like a Pokemon that is a water type, but also can fly. And so, yeah, Pokemon can have multiple types, and types are associated with multiple Pokemon. So therefore we have this junction table of Pokemon and types. And you can sort of see here that the columns that are in this table are Pokemon ID and type ID. Anyone need any clarification? Because the context, I realize, is kind of important. All right. So here, what we do to use SQL in Python, we're going to use Pandas because Pandas is how we display tables. And we're also going to import Sqlite 3. And I'll explain these next things. Import Sqlite 3. So when dealing with SQL, you have a database file. And let me actually show you. I have this database file right here. And this is the database file we're going to be working with, Pokemon.db. If I click onto it, I'm not sure if it'll even render. Yeah, it's not even something that is encoded. It's literally just like a file, Like on the desktop, it's just like that blank icon because it can't be opened. There are several third-party softwares that you can download to see what's in the database. One of them is called Mysql Workbench. And if you download that, you can actually drag and drop files and take a look at what's inside. So I think, Melody, you asked that question about like seeing the tables. That's something you can do. Unfortunately, this work computer has blocked that software, so I can't show you. But if you ever wanted to look into a SQL database, that is something that you can use. So all right, so it is a .db file. So because this .db file is kind of opaque, we really cannot look into it. It doesn't like, unlike a CSV, like here, I have the CSV that like nicely shows me the values. Can't do that. We have to find a different way to interact with it. And the way we do that is with a cursor. It's a little bit hard to explain what's happening with a cursor, but basically Sqlite 3 has this one method that connects to the database file. So what I'm doing here is I'm creating this cursor. You commonly might see it either as CNX for connection or CUR for cursor. Those are the two most common variable names that I see. And you use that to connect to the database file. So if I run this, it's connected to the database file. All right, basically now that we've connected to the database file, every time I run something with the connection, I can read this database. And so, important note on syntax. If you're quoting strings within your query, use double quotes and then wrap your entire query in single quotes. For the most part, most queries, this won't be an issue, but if you ever do end up using SQL in Python this way, just take note of that. Also, I just remembered that in your lessons, I think your labs interact with it slightly differently. They also use this connection, but they do it in a different method where they don't use the pandas read SQL function. I personally think the pandas read SQL function makes sense because we're gonna be doing our analysis in pandas, but just to be aware, I think the lab explains their way well as well, but just for you all to be aware that pandas has this built-in read SQL method that can read queries with your connection. So that's kind of how this is all set up. Any questions before I get into queries? All right, cool. So the base thing you need to know about setting up a SQL query is that in SQL, there are not too many things that you can do. It's just a matter of how you put all these things together. And we'll walk through all the main ones that you will have to know. So the base query first is you're always going to be selecting something from a specific table. So every query has these elements. You have a select statement and a from statement. And the select is basically what columns you're going to choose. Star actually stands for all. And after from, you will tell it what table you're selecting from. So usually when you're writing queries, it's good to have your schema close by. So here, just to show how a select statement works, let's just select everything from this one Pokemon table. So we do that. We first define a string, which will be our query. And again, make sure it's in single quotes because if you happen to quote a string within your query, it will be in double quotes. So what you do is you use the pandas built-in read SQL method and feed it in your query and also the cursor that you're using. And all this output's already here, but let's just run it again. After running this, it takes everything that was in this table, this Pokemon table, and outputs it as a pandas data frame. And now here, you can assign this to a variable and do whatever you want with this data. Questions so far? Awesome. All right. These are the main parts of a SQL query. And I have a bunch of different SQL questions that are going to walk through how each one is used. We're going to talk about select statements, which we kind of did already. Conditions. If you want to select specific rows with specific conditions, we would use a where statement. There are also joins where you can put tables together. There are group by statements, and group by works exactly the same way as it did with pandas. You can use having statements, and having is actually the keyword for filtering after a group by. One actually really random question I've gotten in an interview once is, what's the difference between a where statement and a having statement? Having always comes after a group by. That's just something to remember. Order by, which is how you want to sort the table. So similar to sorting values in Pandas. And limit. So limit, maybe you want to get like the top five rows or the top 100, you would use limit. So these are really the main building blocks of a SQL query. There's not too much after this. I would say anything past this is a little more advanced than what's needed. So for basic SQL, this is really all you have to know. It's just a matter of how you're putting everything together. So these are the keywords. And for SQL, it's actually not case sensitive unless you're talking about like a specific string. It's not case sensitive, but by convention, the keywords are always in all caps. It's just a convention thing. But if you happen to write your query not in all caps, it doesn't matter. Cool. So let's just do a couple examples. Here we selected everything. And as I showed earlier, we're selecting star from Pokemon because star is a shorthand for everything. So if we run this, we'll see everything is there. And just to show, if we want to select specific columns, what you would do, maybe you would do weight and height. You literally just type it in, separated by a comma, and you get weight and height. So pretty simple. It reads very similar to English, which is why I think it's pretty easy to pick up. All right. So next query, we're going to find all the rows from the Pokemon types table where type ID is 3. So if we remember, the Pokemon types table just has 3 columns. It has its own ID, Pokemon ID, and a type ID. So we're just going to get the rows that the type ID is equal to 3. And to do that, we use our where statement, because if we don't have a group by, our filtering keyword is where instead of having. And so here, we're selecting everything from Pokemon types where the type ID equals to 3. And with SQL queries, you're really just building on top of each other. So here, you would select everything from Pokemon types and then add on your filter after that. So if we just take a look, after we do this read SQL, this is the one. It only comes out, we only have the rows that type ID is 3. Cool? All right, now we're gonna build on that a little bit more. Find all the rows from the Pokemon types table where the associated type is water. So here it gets a little bit tricky because if we remember, this Pokemon types table doesn't associate the type ID with the actual type. And actually, let's just query the Pokemon types table so we can see what that looks like. Let's do that here. So Pokemon types is all the numbers, and then the other one is types. So if we select everything from types, we'll see that every type has an ID and also has a name. So we're actually looking for the ones where the name is water. And so by that, we can sort of see here that, all right, water is number 11, so that's kind of a hint. But we want to find out, we want to do that in a SQL way. So let's say we didn't see this, we don't know that it's 11, how would we do that? We know that we actually have to get information from 2 different tables, right? We need to get the information from let me clear this first. Yeah, we need to get the information from the Pokemon types table and the types table. And so what we would do is we would join the tables together. And let me actually output the tables. Let me just output the tables so it's easier to see what's going on. We'll have this one here, and then we'll have this one here. And let me just throw a display statement. So a display statement for a data frame kind of works like a print statement so that you can see both in one output. So here you can see that we have all these type IDs, and we basically want to pick out the ones that have whichever one is associated with water. So when you have two tables that you know you want to get information for, you would have to join them on something, and you very likely would join them based on some ID. And here we can see that, all right, these are the types, and each type has an ID, and this column is going to match this column. So we're going to join the ID column of types with the type ID column of Pokemon types. Does anyone need me? I'll just repeat that again. We are going to join the ID column of types with the type ID column of Pokemon types. And so how we do that, I'm going to actually like make it a little clearer. By the way, if your strings ever get too long, it doesn't have to be in this SQL context, but if your strings ever get too long and it's like out of the cell, what you can do is throw in a backslash, and it will split up your string. Even though it's a multiple line, it'll still read it as one single string. And they actually won't read this backslash, just so y'all know. All right, so let's build this query. What we're doing is we're selecting everything from Pokemon types table. I'll explain this in a little bit, but what we're doing is we're going to join the two tables together using those two columns that I mentioned earlier. All we're doing is we're joining types, because types is the second table that we're using, because we're selecting, let me say that again. We're selecting from Pokemon types. So Pokemon types is our base table, and we want to join our types table onto the Pokemon types table. So therefore, we're joining the types table on, and the on is the condition on which you join. And this is where you tell it, all right, from types, we want the ID column, and from Pokemon types, you want the type ID column. And this is a syntax. You would do table.column name as the syntax to tell it which column from which table to look at. So here we have the join part. Here, this Pokemon types.star is just because we are selecting all the columns from Pokemon types. I'll actually show you what it looks like if I don't have this later. And just for the last part, we already did this similar before. The associated type is water. And so this is just our where condition where types.name equals to water. So let's output this. Oops, here we go. Let me close this. All right. So this, as you can see, all the type IDs are 11, and 11 is water. Here, because the question specifically asked just from the Pokemon types table where the associated type is water, they didn't say to output the water column. I mean, one way to do that is just to get rid of this, because this part of the query is telling it to just output the columns from that first table. If we delete that, and there we go. If we delete that, it'll actually output all the columns from all the tables that you've joined. So it does look a little bit messy. You do have this like repeated column here because this is what we joined on, but you'll have more information. Questions on this? I know I like said a lot of stuff.
Is this an inner join?
So by default, MySQL does a left join, I believe. Wait, let me double check. MySQL default join. No, that doesn't say default. Here, what is the default join? It says inner join. I actually think it's a, I actually thought it was a left join, but I guess it's an inner join. Yeah, I guess it's an inner join. But yeah, that makes sense because it'll only give us, yeah, it's an inner join because it's only going to give us the rows that exist in both tables. But yeah, that's a good clarifying question. Anything else?
Yeah, the backslash for interrupting the string, is that SQL specific or is that Python?
That's Python specific, yeah. So
okay.
Any long string you have, if you want to put it in multi-line just so it's easier to read, you can put that backslash. But cool. There are a lot of like little intricacies with SQL. And so like, yeah, doing this is one of them. So for this specific question, I guess, if you interpret it as like, you know, I just want the columns from this Pokemon types table. Oops. I mean this, Pokemon types dot star. That's how you would do it. Cool. All right, let's move on to the next one. With Sql, if all of this is seeming like a lot of random things, that's because one, it is, and also Sql just requires a lot of practice. So I really recommend like either using HackerRank or there are a bunch of other resources out there, a bunch of other websites. If anyone gets bored with HackerRank, just let me know. All right, here, what we're gonna do is we're gonna find the average weight for each type and then order the results from highest weight to lowest weight and then display the type name next to the average weight. So let me just split this up again so it's a little bit clearer what we're doing here. So you can sort of see here a lot of things are going on. All right, so as you remember, whenever we want to find an aggregation for groups of things, we want to do a group by. And with a group by, it comes with an aggregation, and we know here the aggregation we want to do is an average. So the part that can be kind of confusing here is that with Sql, you actually tell it exactly what you want output. So therefore, we're outputting the average weight. Because we start with an average weight, it's going to look for a group by somewhere. I'll explain all this middle part later, but here we're selecting the average weight and the types.name because we want the weight and then also display the type name next to average weight. It's going to look for a group by. And so technically this is a separate part as well. We're going to group by types.name. So this select average is the aggregation done, and the group by is down here. Now here, we're basically going to be using all of the information from every table. And therefore, we're going to join our tables to each other. Because we're getting weight, and weight exists in the Pokemon table, that's going to be our base table. And the next thing we're going to look at, let's bring this schema back. Actually, let me just copy the schema over lower down. Let me go down here. There we go. Okay. If this is our base table, we're going to join our Pokemon with Pokemon types. And then types actually has to be joined onto the Pokemon types table. If that makes sense. Because of where these lines are connecting, you can see here that you would probably join like the ID column of Pokemon to the Pokemon ID column of Pokemon types. And then you cannot directly join types onto Pokemon. You actually have to join types to this already joined table. That makes sense. You have to sort of do your joins in that order because there is no connection between these two tables. You would have to first join this table to this table and then join this table to the combination of the two. Gotcha? All right. So that's really what we're doing here. I guess the inner join, because that's the default, this is kind of redundant, but what we're doing is we're joining first the Pokemon types table with this condition. The Pokemon ID column of this one is going to match the ID of that one. And then same thing, we're going to join types on the types.id, which is this one, with the type ID of Pokemon types. Cool. So that's the group by and all the joins. Finally, you can order your data frame. So like sorting your data frame, usually when you order by, you would choose one of these things, choose one of the outputs and order by one of those. And then by default it's ascending. If it's ascending, just tell it descending. If we run this real quick. Ooh, what happened there? Did I forget? Did I forget something? Line 5. Let's do this. I think this double line might be what's, yeah, there we go. So no multiple lines between. But anyways, what we have here is the average weight and the name, and it's also ordered by weight here. questions about this? We did multiple joins and we also did group by in this example. Awesome. With those practice examples on your lessons and also on HackerRank, they talk about each concept separately, so it might be a little easier to digest. All right. I think I have 6 altogether, so almost done. Here, we're going to find the names and IDs of the Pokemon that have more than one type. So we remember I mentioned that Pokemon can have multiple types. We're just going to look for all the Pokemon that have more than one type. So let's again split this up. There we go. Here we're going to see the use of a having. So here what we're doing again is we're choosing the ID and name from Pokemon. And here, even though, oh wait, yeah, just name and IDs, yeah. Because we're joining the tables, something that's always a good practice to do is to tell it which table you're pulling from. Just because after you join your tables, the other tables also have ID columns, right? Like, and I think the other table also has a name column. If we look up here, this table also has an ID and a name column. So if we actually don't have this table name here, it'll actually throw us an ambiguity error, which actually I think we can take a look at real quick. There we go. I guess, yeah, ambiguous column name of ID. And so that's something to just take note of. Sometimes different tables have columns with the same name. That's why you want to do that. Let's undo that. All right. What we're doing here, names and IDs of Pokemon that have more than one type. So what we're going to do, all we need to do to know, to get the information for this, we don't need to know what the type is. We just need to know that, we just need to know if the Pokemon has multiple types. So here we don't really need this types table because we can just have the numeric representation of the types to count how many types each Pokemon has. So what we're doing here is we're actually going to use a group by. Might not seem like it, but we're going to use a group by. So first, we're selecting these columns. We're going to join the types, the Pokemon types table, the one with the numbers. And then what we're going to do is we're going to group by Pokemon ID. So that means each Pokemon ID is going to be a single row. Does that make sense? Each Pokemon ID is going to be a single row. And then what's going to happen is the aggregation here is in the having statement. The aggregation here, because we're not outputting the aggregation can be here. If we want to see the number of, if you want to see like the number of types that a Pokemon has, yes, we can output that up here as well. But actually, let's just keep that there for now. But yeah, this is where a condition from the aggregation comes into play, which is why we use the having statement. Does that make sense when we use like a having versus a where? Because this basically this filter depends on the aggregation. Therefore, this is using a having statement instead of a where statement. But let's just output this and see what we get. So here you can see they asked for the names and IDs, but I just put this here just so we can see what's happening. We have joined that second table of Pokemon types. And after joining that second table, actually, let me take these out so we can see step by step what was really happening. Let's take out this part. Oh, I can't even comment this out because it's in a string. That's cool. Let me quickly do this then. So without the, yeah, that syntax should be right. Without the group by, what we have here is, and let me just also get, and also we want Pokemon.types. Hold on, let me see which one I can get the types from. Type ID. All right. here you can see without doing the group by, now we actually have multiple rows per Pokemon. So here you can see that like Bulbasaur, which is a Pokemon, has types 12 and 4. Same for this guy, 12 and 4. This guy down here has 16 and 3. So the group by that we're doing is we're grouping for each Pokemon that has multiple types, we're going to just aggregate them and then just count how many occurrences there are. So that's what this group by statement is doing. Did that make sense? Please ask any clarifying questions. But yeah, that's what the group by is doing. There we go. And after we do this group by, we have this additional filter where we only want the count more than one. I'll actually also show an example without this. Without this, we'll have, hold on, let me get rid of this as well. Here, you'll see that every Pokemon comes back out. We have 1, 2, 3, 4 through 50. But when we throw in this having statement again, we have the type ID. That makes sense. Actually, I think it's easier if I show this. There we go. Here you can see the count is 2. Without this, you have 2s and 1s. And so that having statement only gives you the ones that appear more than once. Cool? All right. Our last query. Find the ID of the type that has the most Pokemon. So as I mentioned, types are associated with many different Pokemon. Find out which one has the most. And we just want the type ID next to the number of Pokemon having that type. So, all right, here we're going to introduce a couple new things. First of all, we are doing, here we're not doing a join because here we know that, we're not doing a join because all the information that we need from this can be found from that junction column, from that junction table, sorry, from here, because the number of rows in this, every time you have a single Pokemon and type relationship, there's a new row. So because of that, we only need this table. Let me move this down so we can see that. All right. So what we're doing is we're again aggregating the Pokemon ID. We're aggregating by the type ID, and we're going to count the Pokemon ID within that. If that makes sense. So what we're doing here is we're selecting the count of Pokemon ID, counting how many Pokemon IDs appear in each type. And what we're doing here is we're aliasing that. So earlier you saw when I did like this output of like an average, automatically the header becomes average of weight. Something else you can do is you can alias it by saying select this column as number of Pokemon, just so it's easier to interpret. And then we also want to get the type ID from the Pokemon types. So here we're grouping by type ID because we want to find the ID of the type that has the most Pokemon. So per each type, we want to count how many Pokemon exist there. So that's why we're grouping by that. And then we're going to count the number of Pokemon IDs in each type ID group. And then order by the number of Pokemon descending, and then limit 1. Here we're just taking the top one. So if we don't do the limit 1, we actually have all the different types ordered by the number of Pokemon associated with that type. And the limit 1 just gives you the top one. And those are all our basic SQL functions. Any questions?
The count method is like the sum method in Pandas?
Kind of. Count is literally counting how many rows are in each group by. Where sum, if it was like numbers, it would actually add the numbers together. But in this case, we're just counting how many rows. Does that distinguish?
Yes.
All right.
And can you explain a little more about primary key and foreign keys?
Yeah. So foreign key is something that we're not really going to talk too much about, but foreign keys are typically something like this. If you have like a key here that is associated with a key from another table, that's usually what a foreign key means. And there is a little bit of like, depending on the kind of database that you're using, sometimes those relationships can already be coded into it, so it already knows. Primary key, for the most part, is just the incrementing integer as you're putting in more data. So here, it just so happens that like the idea of a Pokemon is the order in which they're, I guess, created. And so, yeah, usually a primary key has to be unique, just so like every row has an identifier, and it's basically the identifier for the row. That's a primary key. And foreign key, in a similar sense, it would identify rows in another table, in a foreign table. Did that help?
Yes.
Please, like, feel free to, like, if something didn't make sense, just let me know. Cool. Let's see, what else I want to say. Yeah, I just think like for SQL, it's really important to practice. Not to worry, because I understand that there's a lot of stuff going on with like pandas and visualizations, and the project does focus on that. You can choose to use SQL in your project, and I will talk a bit about how you can do that when I'm introducing the project next week. So if you really want to practice SQL, there are ways to incorporate that, and I'll let you know how. But for the most part, you really only need to know like perhaps this level of SQL when you get to interviews, because a lot of interviews just have SQL components. On the lessons, so if I go into the lessons, there is actually a few really good, ones for practicing SQL. There is one lesson that actually has a combination of interview questions. Oh, right here. A combination of interview questions collected from different companies. And so this is just a good one to take a look at and see like, all right, this one came from Facebook, this one's from Amazon, just to see what kind of SQL questions they ask. Downside, we actually don't have these SQL databases, which is actually quite common. Sometimes they ask you to just construct a SQL query with the schema, or they'll tell you a little bit about the table, and you'll just like assume some column names, and you just want to sort of see a pseudo code of how you would construct the SQL query. Just so you know, like, because it is quite vague when you get to some of these questions, just to let you know. Any other questions about coursework?
Which lab is that one?
This is SQL Interview Questions Lab. It's right at the bottom of topic 7.
Okay.
Mm-hmm. It's a good one to know. I will, like, once in a while be sending out SQL questions as our morning questions as well. So we'll have some practice.
I had a question about working with a database.
Mm-hmm.
When you show us like the image of the employees and the salaries, which is like a bunch of little databases or whatever the term is.
Wait, I have it here. This one, right?
Yeah. My first instinct is like create a brand new database, dump every single column into that, and then don't work with joins anymore. You just work with one database. Is that like an option?
I would say like that is pretty much the reason why you don't have to do the very complicated SQL things, right? You can like take that a step further and just like import everything into like Jupyter Notebook and Pandas and just work with it there. You can literally like import everything. Maybe use like Pandas joins because it's like easier to debug for sure. That's something you can do. Sometimes SQL databases are just so big. You can imagine like companies like Facebook, Amazon, they have all the data in the world. So you can't import all of that into a Jupyter Notebook or onto your computer sometimes. I was like working with Yelp data once and it turned out to be like 6 gigabytes and it like ruined my computer. So sometimes databases are just so big that you just have to work with subsets of it, and to get like the specific subsets that you need to like work with some queries. But yeah, that's definitely something you can do. One group that I had for my last cohort with their phase 1 project actually decided to just stick all of the, you'll see you're provided with about like, I think 9 different tables, and they just like stuck them all together. Pros and cons, you just end up with a lot of like duplicate rows of things that you might not actually need. But yeah, pro of that, everything's in one place. But yeah, it's kind of up to you how you want to work. Just sometimes can be a little less memory efficient. Anything else? Cool. Before I move on to our Friday feelings, I do have like a list of announcements that I wanted to talk about. So first off, Monday is a holiday, so you guys can still work by all means, but I nor technical coaches will not be on Slack for support on Monday. So just take note of that. Also, I've been noticing that my one-on-one slots have been booked up at the end of the week really, really quickly. So most people actually have recurring slots on like Wednesday, Thursday, Friday. So it has been hard for those of you who don't have recurring slots to get those times. So if you prefer having your one-on-ones later, highly recommend, let me know. I can try and find any recurring slots that are left, or just book them more in advance. Because I know there are some of you that actually didn't get one-on-ones this week because of that. So yeah, book your one-on-ones earlier. Also, Pandas exercises. I think like if you don't want to spend time on something that your project might not need, like Sql, and you're done with the labs, I think a really good resource to check out is the Pandas exercises that I put up yesterday morning. This is not something created by me. This is something that's created by this guy. And he just put together a lot of really good Pandas questions for you to practice specific things. So maybe if you're not too confident about like, doing group by, there are many different, well, here are 3 different data sets that he actually has like guided questions on how you would use group bys. And you can see that it has like different examples. It sort of brings you through like a data cleaning and data exploration process with Pandas with different data sets. So if you feel like you need more Pandas practice, my last cohort really, really liked this resource. So definitely check it out. I think it's a good use of time as well. Also, I have mentioned the project quite a few times. It's actually up on phase 1, right at the very bottom under, it's gonna look slightly different from what it looks like on mine, but it's called, what's it called? Phase 1 project online. So you'll see that you'll be able to take a look at what the project's expecting, what the project's about. It's a pretty fun one. But always good to like take a look before we fully dive in, so that before Friday, which is the hour that I'm going to use to introduce the project, you'll be prepared with questions as well. But yeah, any questions on anything I just said?
Where we can find the resources that you mentioned earlier about Pandas?
I'll send it out again. I sent it out in Slack, but let me just send out the link one more time right now so that it is there. Yeah, that will be there.
Thank you.
You're welcome. Any last questions? Cool. In that case, I'm going to stop the recording and we'll start our Friday feelings. All right.